Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're gonna discuss the lead code problem of the day. Count good triplets. So you are given three integers, A, B, C, and you need to find the total number of good triplets in which array of I, array of j, array of k is good if they met the following conditions are to be true. In which I should be less than k, j, j should be less than k, and it all should lie between the boundaries 0 to n will be the size of the array, and it also needs to be meet all these three conditions, which is array of I minus array of j modulo should less than or equal to a, and array of j minus array of k modulo less than or equal to b, and array of I minus array of k modulo less than or equal to c. If they meet all these conditions, then it is a good triplet, and we need to find the total number of good triplets on this particular array. So, the brute force way, in the brute force way, what we can do is we can iterate I from 0 to n, which is the size of the array, and the j same way, which is j should be I plus 1, because as we can say, I should be I should fall before the j, right? So if j needs to be fall after the I, then definitely it should, the minimum index that should be present is I plus 1. Then only we can say j is greater than I, or you can say j is I is less than j. Okay, j less than n, j plus plus. For int k equal to 0, sorry, k should be j plus, k should be j plus 1, k less than n, k plus plus. Then if condition 1 less than or equal to a, and condition 2 less than or equal to b, and condition 3 less than or equal to c, in that case count plus plus. Finally return the count. So what is this condition 1, what is this condition 2, what is this condition 3? It's nothing but these three conditions. These three conditions. Condition 1, condition 2, this is the condition 3, which is ABS of this thing, array of I minus array of j. That would be the condition 1. So if it is less than or equal to a, then condition would be true. C1 will be true, and C2 will be same was. So this is the brute force approach. And what is the time complexity of this solution is, as we are iterating thrice inside a nested for loops for each. So for each value of I, we are running j n times and k n times, right? So what is the total and this I also needs to be nested from 0 to n. So what is the time complexity of n cube? What is the space complexity? So time complexity is O of n cube. Space complexity is O of n, because as we are not using any other data structure, so this solution will work as per the constraints. N is less than or equal to 100. So n cube is 100 cube, that is 10 square whole cube, 10 power 6, which is less than or equal to 10 power 8. So definitely it gonna submit, but we we always tends to find the optimized solution. So we need to figure out the optimal solution. So for that, so if you carefully observe, we need to get rid of one of the loop. Suppose if you want to get rid of the kth loop, so what we are trying to figure out until now is, suppose if the value of I is here, and if the value of j is here, suppose condition 1 and condition 2 are met, then we need to figure out what are the other values that satisfies the condition k on the right side part of the array, so which is difficult to find. So for that we need to iterate for the k as well again, so that will again lead to of n cube solution. So instead what we can do is we can eliminate this ith loop. Okay, we can eliminate this ith loop. Suppose so how we can eliminate this ith loop? So so suppose in the number line the j is here, the k is here. Suppose you want to find the ith index, we can use a prefix array that are the prefix array of count that satisfies this condition. So we don't need to iterate over the right side part of the array. We can instead we can store the values on the prefix array, and we can directly get the count of these elements which we are traversed before. So while you are traversing, we are maintaining a prefix array. So prefix of x represent count of numbers that are less than or equal to x. So with that with that instant we can directly get the value of the numbers that are less than or equal to x, and we can directly add into a answer variable. Okay, so that is prefix count of some, let's say, x or something. So instead if you eliminate k, we need to iterate on the right side part of the array, which we didn't know yet. So what are the values that are less than or equal to x? But what if we eliminate I? As we traversed before, we know how many values are less than or equal to x and which satisfies this condition, so we can directly retrieve from the prefix array. So that's why we are eliminating ith iteration instead of the kth iteration. Okay, now if you have a clarity, so I would prefer you follow the of n cube solution if you are not aware of the prefix sum solution, because as it's not a beginner solution, it's an intermediate problem. So if you are a beginner, just follow that O of n cube. It's definitely gonna submit the solution because the constraints are very low. And if you are intermediate and if you know how to use the prefix arrays and all, then do follow this, do continue this video. Okay, so now we know we can able to figure out the left side part using a prefix. So let's just see. Suppose for right now, right, j is equal to 0, j less than n minus 1, j plus plus. Another loop, k, k equal to j plus 1, k less than n, k plus plus. Okay, so as you can see, if it is a j, okay, and this is I. So the difference between ij, not the difference between the indexes, difference between the values of I and j should always be a less than or equal to a. Okay, so I think that's the conditions. Let us see. So I minus definitely that should fall under k. And for the k, j minus k should always less than or equal, difference between these two elements should always be less than b. And for these two values, the reference all should always less than or equal to c. Okay, so that's the constants that are given. Suppose we don't know this ith value. Okay, and if you take this number line, this is the j, this is the k. Okay, so So how you get, so how do we get I? As you can see, as you can see, I minus j less than or equal to k. As if we don't have a, if you don't have this ith value, if you don't have this ith value, so how you gonna get, suppose let's take x. So wait, I'll just copy this solution. I minus j, j minus k. So array of I minus array of j less than or equal to a, right? If you remove this abs, so if take this as x, so x minus a equal to array of j, x plus a equal to array of j. So if you want to find the, so we need to find x, right? So x equal to a plus array of j, x equal to array of j minus a. So definitely that I the value should lies, suppose this is plus a, this is minus a. So definitely that should lies between these values, okay? And how? So array of, let's say j plus j minus a, j plus a. And what for the kth value? It should lies under plus k minus k. Suppose it should lies under this index. So in order to satisfy all three conditions, so in order to satisfy all three conditions, definitely it has to be lie under this intersection part. So it is the leftmost jth value and it is the leftmost kth value. So it, in order to lie in this part of the intersection, how you get, so we need to get the maximum of these two values, maximum of the left part of the left part of k, then only we can say that would be left part should lies in this intersection, okay? And so let's write the conditions here. Int left part equal to max of left j comma left k. And what would be the right part? So right part for the jth part, right part here, and kth part, right part here. It should be the minimum, then only that falls under the category. So we have this is right j, right k. So how these out of these two values will fall under this cross section? It should be the minimum value, then only it will falls under this cross section. So minimum of right j, right k. So that is the conditions that need to be checked. And as we know how many values that satisfies this j and kth value, that is prefix of rightmost minus, so that is the prefix of rightmost minus prefix of l plus, sorry, l minus minus 1, that is the count. So it is the, so as we can able to find the range of the values for the index I. And how do you find the count? So this is the rightmost count from 0 to rth value, and this is the leftmost count from 0 to lth value. So we'll directly separate r minus until l minus 1. We'll separate until l minus 1 count. Separate until l minus 1, we'll get the total number of count between the left and right value. It is the basic of the prefix sum solve. And let's just jump into the code, you'll get clarity around the problem. So what I'm trying to do is just having a size n and the count as 0. I'm also need to, I'm also maintaining the prefix sum with the 1001 integers, because as the constants are a b c as array of value can go up to 1000, so I'm just maintaining 1000 and 0. j iterating from 0 to n minus 1, k iterating from j plus 1 to k. So first check that needs to be checked is the array of j minus k should be less than or equal to b. Then only we'll check for the ith value whether that falls under whether ith value oh, can able to falls under these two conditions as well. If the starting condition is false, then no point in checking the other two conditions. Okay, so we'll check for the j minus k less than or equal to b. If it is true, what we are trying to find is we need to find left and rightmost part of the i's in which the conditions definitely be true. So in order to find the left and right value, we need to find the left j value, which is array of j minus a, and left k value is array of k minus a. So subtracting from their respective values, that will be the left j left k, and what is the right j and right k? Adding the values, right? So as I told you, if in order to fall under this L and R, not to fall in the cross section area, L has to be the maximum value, max of L, J and R, okay, and R has to be the minimum of R and J, okay. So if you carefully observe, if the value of A is larger than the array of J, then might be a case L becomes less than 0. But what does prefix sum do? It is the count of values that meet the conditions, right? So never be a case where the count is minus 1. You can say there is no count of I for in which j and k satisfies the condition, but I doesn't meet the condition. In that case, the count will be 0, but the count never be a negative. So we are ensuring that L should be max of L comma 0. If it is less than 0, then the L becomes 0. Why? R is minimum of 1000 under. At a max the count of elements would be 1000. So there is no point in the count will increase from 1000. So if we see the a value is higher and if suppose if a value is 1000 and array of j value is 3, then what is the count? 1003. The maximum element that can guarantee in this array is 1000. So how can it increases from the 1000? So in order to ensure the constraints, we are writing r equal to minimum of 1000 or r. So that does not lead to a outbound conditions. Okay, so and also we need to check L. Definitely L should be less than or of. Suppose if there is no what do you say, cross section in between these two areas. So suppose I'll let you know. Suppose if this is area 1 and this is area 2, this is LJ RJ LK RK. So if you see there is no cross section in between these two regions. So if you take max of LJ RJ, that will be R, right? So that will be the L. So L is here. And if you take minimum of RJ and RK, K is here. If you carefully, R is here. So if you carefully observe, R is less than L. So there won't be any values of I in which it will meet all these three conditions. For that sake, we need to check L definitely should be less than or all. Then only we can able to figure out all the conditions meant to be true. Okay, so that's what we're doing. L is less than or k, and count plus plus prefix of R minus prefix of L minus 1. But there might be a case where L is the starting index 0. So 0 minus 1 will lead to a outbound condition. We are getting the index as minus 1. For that case, if L minus 1 is greater than 0, we are using ternary operator. If L minus 1 is greater than 0, return prefix of L minus 1. Or in other case, just return 0 from there. So that will get you the count of these values. So of each iteration of j, we need to update the values for I in the prefix sum. What we need to so what we need to update, as I told you earlier, what is the prefix of I? Prefix of x. It is a count of values that are less than or equal to x. So if you want to update a particular value of j, then we need to update all the values of array of j which are greater than array of j, which are greater than array of j. We need to update for all the values which are greater than array of j. So for that we are writing inside this jth iteration for index starting from array of j and index less than 1000, update the prefix of index by 1 and in the end return the count. So what will be the time complexity of this solution? So time complexity of the solution is of n square plus n into m. So what is this n? Probably 100. What is m? Because we are iterating from array of j to 1000. So m is in the worst case 1000. Here n square 100 square. So what is the worst time complexity solution? Of 10 power 4 plus 10 power 5. So probably you can say of 10 power 5 will be the worst time complexity. Instead of n square, we're taking nm because here m is greater than n, right? So worst case time complexity is of n into m. What is the space complexity? Space complexity, as we are taking a prefix data structure, that is O of m. M is 1000 because we are storing the 1000 values. So it is still better than of n cube solution, which is 10 power 6. So it is more optimized than the brute force solution. And let's just submit this code and check. Voila, it's submitted. And that is for today video, guys. So if you find this video helpful, do like the video and share it with your friends and subscribe to my channel so you'll never miss, and hit that bell icon as well so you'll never miss any notification from my channel. And if you had any queries regarding my explanation or regarding the code, do put it in the comment section. I'll help you out, guys. And that's it for today video, guys. Thank you. Tata, bye bye. See you tomorrow with a great content. Bye bye.